Hello, is my screen visible? Okay, thanks. Let's wait for 5 more minutes and then we will start today's session. Am I audible now? Okay, thank you. Okay, I think we can start today's session, and meanwhile the other students can also join. So in the previous lecture, what we were covering was related to in the previous lectures what we have covered so far. It is uh, the number system, then floating point representation, few basic logic gates, then combinational circuit, sequential circuit, memories, then something related to state machines as well was also covered. Then we covered microcontroller and hardware description languages. So in today's session, okay, in today's session what we are going to do is so it is the same microprocessor, but it is an extended version of that, and we will try to solve a few questions related to those concepts. So let us start. Okay, so the first question is, the stack pointer always points to which location? Can someone answer this question?
The location which is defined by the user, just before that location means -1 of that.
Okay, so can you be a bit more generic, like
if I'm defining like a LXI SP FFFF, then it will point out FFFE location.
Okay, yeah, that is kind of, so it is actually pointing at the top of the stack, right? So we can say, because it is mentioned that always points to which location, so it is actually top of the stack. So
yeah,
it points to top of the stack. Okay, so the next question is related to what happens when this instruction is encountered by 8085 microprocessor. So in this question, so before jumping to this question, so I would like to give a brief recap of the subroutines part that was covered in the lecture. So what is a subroutine? It is a group of instructions that means that is used. Okay, just give me a minute. Yeah, so that is used repeatedly in different locations of the program. Okay, so let us say there is a particular task which can be used by different sections of the program. Okay, so instead of writing that task several times, what you can do is you can define a subroutine, and that can be called several times. Let's say that's a 5-line code or something, so you need not write 5 lines each time. You just define that subroutine in a location, and you just do the call to that subroutine. Okay, so that is what a subroutine is, and so it can exist anywhere in the code in assembly language, but it should be separated from the main program. Okay, and so for in 8085 there are two instructions for dealing with subroutine: the call instruction and the return instruction. Okay, so the call instruction is used to means send the program execution to the subroutine, and after that execution is completed, it has to return back to the next location. So the return or RET statement is used, RET instruction is used in that case. Okay, so then comes the conditional call and return instruction. So let me write it down. Okay, so 8085 it supports a few conditional call and conditional return instruction. Okay, so the conditions, the same conditions that are used for the jump instruction, they can be used. So CC, so we have something called CC. So it is call subroutine if carry flag is set. Similarly, CNC is call subroutine if carry flag is not set. Okay, so you remember we had a number of flags available to us, right? So one of the use of those flags were to execute the jump instructions. So here we see another example of how those flags can be used. So if the carry flag is set or carry flag is not set, so for any kind of conditional statement, those these instructions can be used. Okay, so CNC 4001 4001H, it means that like call subroutine if the carry flag is not set. Okay, but what happens when this instruction is encountered by the 8085 microprocessor? Okay, right, so it will basically call the subroutine that is located at the 4001H location if carry flag is not set, right, because we are using CNC. Fine, so 4001H is the location. Yeah, option B is the correct answer. So 4001H is the location where that subroutine is located. Okay, okay, so which of the following instructions control the interrupt enable flip-flop?
EI.
Correct, EI is enable interrupt. Okay, similarly, so the interrupt enable flip-flop, it is controlled using basically two instructions, so EI and DI, right? And what is actually an interrupt? So it was also it was also covered in the lecture. So it is like it's a process which is means it is kind of getting the attention of your microprocessor. So where any external device, it can send that request, right? So it's asynchronous, and so these interrupts are classified into two types. So there are two different type of classification. One is on the basis of the maskability, like whether it is maskable or non-maskable. Another thing is like whether it is vectored or non-vectored, means the address of the service routine is hardwired, then it is called as vectored. If it is non-vectored, then it means that this address needs to be supplied externally. Okay, and whenever the microprocessor receives an interrupt signal, it suspends the currently whatever program it is executing, and it jumps to the interrupt service routine, okay, to respond whatever interrupt is received. Okay, And yeah, so enable interrupt and disable interrupt are two of the instructions that set this interrupt enable flip-flop. Okay. Okay, so moving on to the next question. Okay, which of the following instruction is equivalent to call 0028H? Option B. Does everyone agree with this? Okay. Yeah, so RST5 is the correct answer. So when a RST5 instruction is executed, so transfer the program execution to the appropriate entry in interrupt vector table. So interrupt vector table holds the location that which instruction needs to be called. And so there are several such interrupts available, and so 8085 has 5 interrupt input, the INTR input, then the RST 5.5, RST 6.5, 7.5, and trap. Okay, so there are various properties that are listed in the lecture slides, so I'll suggest you to go through them. So there is a differentiation table available that which interrupt is maskable and which interrupt is vectored. So it is better to keep in mind which interrupts are maskable and which interrupts are vectored. Okay. Then yeah, and okay, so there is another thing. So each this restart instruction, it is at an offset of 8. Okay, so let us say it is RST, so it is equivalent to call 000H, sorry, RST0. Okay, similarly RST1 is equivalent to call 0008H. Okay, similarly RST2. Okay, so what will be the location of RST2?
0010H.
Correct, 0010H. Okay, so similarly if you go on, so you will arrive at RST5, which will be 0028H. Okay. Okay, so question 5 and question number 6 are linked. So can anyone tell me what is a T state? So we discussed about T state in our previous session. So if I say, okay, yeah, so if I say that this instruction takes one T state, so what does it mean? So how do I convert one T state into the time unit?
One time period is equal to one T state?
Correct. So basically one time period is equal to one T state. So one time period means 1 by the operating frequency of my microprocessor, right? And this question asks the CNC instruction, call not carry, how many T states is needed by this particular instruction. So the answer many people have already written, that is option D, that is 18. Okay, so this is the instruction that takes the longest delay, right? So okay, how long must INTR interrupt remain high to be sensed by 8085 processor?
17.5 T states.
Correct. So it has to the INTR interrupt, it must remain active long enough to allow for the longest instruction, and as we saw, the longest instruction was the call instruction, which requires 18 T states. So it has to stay active for at least 17.5 T states. Okay, so 17.5 T states is the answer. Okay, so now next thing is related to setting the interrupt. So I'll first okay, so this is reset 7.5, sorry, RST 7.5
B, I think.
E. Yeah, so basically enable interrupt, what so the SIM, what it will do is, SIM stands for set interrupt mask, and whatever value is present in the accumulator, based on that this complete register value is set. Okay, so in this particular instruction, what we do, we move the value 2A to 2AH to A. Okay, and then we do the set interrupt mask. First we do the enable interrupt, and then we do this. So if we do 2AH, then the RST 6.5 interrupt is masked. Okay, option B is correct. Okay, so which of the following is not a valid 8085 instruction?
Pop D.
Pop C.
Okay.
Pop C.
Yeah. Okay, yeah, correct. And why?
Because in case of push and pop instruction, we have to mention the first register name of that pair.
Okay,
That's why.
so what would have been the correct answer? Matlab, like instead of pop C, what could have been written?
Pop B.
Yeah, so pop B will take care of both B and C. Okay. Okay, so question number 10. Okay, so with respect to 8085, match column X with column Y. So can anyone tell me? Okay, let's start with RST 7.5. What is RST 7.5? Is it level triggered or edge triggered?
It is age triggered.
Correct. So RST 7.5 is edge triggered. Okay, so let me tell you what is edge triggered and what is level triggered. So edge triggered means whenever a positive or a negative edge arrives, so based on that a particular execution happens. Let's say there is a signal called X. So X goes high as soon as the edge is received. Okay, so that is my edge triggered thing. But what is a level triggered? So level triggered means, and it will execute only during the arrival of the edge. It cannot be executed somewhere in between here. Okay, but in case of a level triggered, so what will happen is it will trigger if in case of if it detects high level. Okay, so if it is sensitive to high level, then what will happen is it will see when the signal is high, and at that instance it can go high. Okay, irrespective of whether the edge is received or not. Okay, so 7.5 so RST 7.5 is an edge triggered okay, so similarly what can you say about RST 4. What can you say about RST 4.5? Can anyone answer this?
Edge and level.
Okay, RST 4.5 is edge and level. What is RST 6?
Software.
Okay. And what is RST 5.5?
Level triggered.
Yeah. Okay. So you need to remember which one is edge triggered and which one is level triggered. So in the lecture slide around page number 48, okay, so it is mentioned, so which one is level triggered and which one is edge triggered. So you need to keep those things in mind. Okay, now moving to the next question, which group of instructions do not affect the flags?
Data transfer.
Correct. So can you give an example of a data transfer instruction?
Move instruction.
Correct. So option C is correct. So if let's say I'm doing move a comma 00h, okay, so it is not going to set your that 0, right? It is not going to detect that it is a 0 or something. Okay, but on the other hand, logical operations or arithmetic operations, so they are going to affect your flags that are available here. Okay. Okay, so in 8086 microprocessor, so this question is related to 8086 microprocessor. Which of the following registers can be combined together to be used as an accumulator register?
A.
Correct.
AL and H.
Yeah, AL and AH. Okay, so moving to the next question, which of the following is performed by execution unit in 8086?
Instruction execution.
Yeah, it is instruction execution. So 8086 is a dash bit.
16.
Correct.
16-bit.
16 bit. Yeah. So okay. So I would like to tell a few more things. So means I would like to recap a few things that was covered in the lecture and that can be helpful for you for your preparation part. So one of the things is related to the call instruction, the subroutine part. Okay, and yeah, I have one more announcement to make. So this is not the last live session that I'll be holding. So there will be another live session that will happen next Saturday. Next Saturday is 21st, October 21st from 3 in the same time, 3 p.m. to 5 p.m. So in that particular lecture, what I am going to do is so till date, whatever questions we have solved, so we have solved roughly 180 questions. So out of those 180, only the questions which are having numerical component, okay, and which have a conceptual component which needs greater attention, that can be helpful for your exams and all. So I'm going to pick those questions, and so that will be a form of revision for you all, so that most of the concepts that we have covered so far, it gets revised again. So that is what I'm going to do. And if you have any doubt related to any portion that is covered during that session, means from week 1 to week 12, okay, so we can discuss those things as well. So yeah, so next Saturday, that is what I'm planning to do. Okay, so as I mentioned that I'll try to recap a few things that was covered during the lecture. So one of the things is the call instruction, right? So let's say the call 4000H is used. So what will happen is this address, it will get pushed into the stack. Okay, so sorry, the address that is next to this instruction, that will be pushed into the stack, and 4000H will be pushed into the program counter. Okay, and then when the return instruction is executed, then the return address from the top of the stack, that was the next address to the call instruction, that will be retrieved. Okay, and the program counter will be loaded with the return address. Okay, and yeah, so there will be a few cautions that we need to take with the push and pop operation. So these operations were these instructions were related to the stack, and so there should be equal number of push and pops. Okay, and there are a few good practices that needs to be taken care of, so while using a call statement or a return statement. Okay, so there is something called as a proper subroutine that is termed in a good engineering practice form. So there should be a single entry point. Okay, let's say that you have a subroutine in which you have multiple entry point. Like if say you are doing this call X, call Y, it's the same subroutine. Okay, but call X points to this location, call Y points to this location in the same routine, then this is not a good practice. Okay, so there should be a single entry point. Okay, then yeah, so do not use call statement to jump into the different points of the same subroutine. Okay, this was regarding the call and return instructions that you need to keep in mind. then few things related to the interrupts, like so response to an interrupt, it can be immediate or delayed depending on whether the interrupt is maskable or not. Okay, and the non-vectored interrupt, so the address has to be supplied by the device which is calling for an interrupt. And I'll suggest you to remember what are the vectored interrupt and what are the non-vectored interrupt. So this was covered. So there was a table. So I'll note it down. Okay. Okay, so INTR is maskable, but it is not vectored. Okay, RST 5.5 is both maskable as well as vectored. RST 6.5 is both maskable and vectored. 7.5 is also maskable and vectored, but trap is not maskable and it is vectored. Okay, so this table you need to keep in mind. Okay, and then I mentioned like how to figure out which particular restart instruction is being called, just like we did for call 0028H. So that was RST 5. So similarly you can be given any instruction like this. So it can be call 0018H, and you should be able to figure out what is it pointing to, RST X. So what is X here? Okay, so you should be able to do that, because as mentioned, the RST 0, it represents call 000H, and every other RST X is actually at an offset of 8. Okay, in hexadecimal, right? So taking this information, you should be able to figure out what is that restart instruction and what is it equivalent to. Okay, so yeah, this was more or less what I planned to cover today. And yeah, someone has raised a hand. Sure.
Yeah, I have actually doubt in to how to find out the T states of any instruction. In that case, I have some doubts. Could
Okay.
you please explain it again?
In which case?
In any instruction, how will we find out how many T states we need
Okay.
to execute that instruction?
Actually, what we used to do is so it is difficult to say it from the instruction itself, but yeah, Suresh, just a minute. So you want for any particular instruction how to figure out how many T states it will take?
Yeah.
Okay, actually I need to look into this. Means I also don't remember. But what we used to do is we used to check the. I mean, if it is a data operation, then we used to see whether it is being directly addressed or not, and based on that, there was a method. So I'm sorry, but I also forgot. I'll check it once, and maybe
Yeah,
in the
it's
next
okay.
session. Yeah, in the next session, I'll try to answer this query.
Okay.
So there is another thing that we also can do. We can just remember the basic instructions, but yeah, this is actually a good question. So I'll look into it and I'll let you know by next session. So yeah, as I mentioned about the next session, so next session will take place on 21st, and yeah, whatever queries you have, you can let me know. I'll try to address them in the next session itself, and yeah, I'll also try to answer this question that someone asked, and we will only be solving problems. So these questions are getting over quickly because these are mostly factual from week 11 and 12. But what I will be doing on 21st is I'll be solving I'll be covering all the conceptual questions that we used to solve in the beginning, right? So those sort of questions, and I'll pick the important ones that will cover all the concepts, not all, but most of the concepts that need some thinking. Okay, not the remembering part. So yeah, so that's it for today, and if anyone has any other doubt, then they can let me know. Okay, so when is the exam?
Next Saturday.
Okay, it is
28th. 28th.
Okay, so I think there is sufficient time for preparation, and yeah, most of the questions will be related to what we have covered during our sessions, and yeah, so for revision part, you can go through the previous lecture videos recording. Anyways, I'm going to solve the numerical questions and those conceptual problems in the next session. And so what I will suggest is you can go through the previous lecture recordings, and if you have any doubt at any portion, then just note it down, and during that session you can feel free to ask, because I saw that in the forum not many people are asking questions, but they have some doubts. So one person messaged me on the YouTube channel itself, but that is means it can't be explained there effectively. So this upcoming session is the best place where whatever doubts you have, you can get it cleared. So okay, so yeah, so let's meet on 21st. Okay,
Shall we have a recap of today's?
sorry, can you repeat?
Shall we have a quick recap of today's questions? Actually,
Yeah.
I joined in the middle.
Oh, okay, yeah, sure. Okay, so I'll give a recap of today's session. So others who were there, means if they want to stay, they can stay, otherwise they can leave, and we will meet on 21st same time from 3 to 5. Okay.
Just one question before that.
Yeah.
If you can go to that call instruction, right? Earlier you were talking about. The recommendation for the engineers.
Yeah. Okay. This one.
Good practice, yeah. Here, for example, if I want to do some two variables are there, I want to implement all the arithmetic operations with call X function, let us say.
Okay.
In the call where I need only addition operation. In that case, this is good practice, right? I mean,
Sorry.
how to
I didn't get the question. Can you repeat again? If call X is?
call X is all arithmetical operations I want to go with. all arithmetic, addition, subtraction, multiplication.
Okay.
And call by is only dedicated for only addition, let us say.
Okay.
So in this case, if I call x, it will do all the operations which are.
Okay.
Yeah. So sometimes I require only addition. So in that case, in the same subroutine can be utilized for the both, right? Individual as well as the combined.
Yeah, but if you are having multiple call instructions, then you will have multiple return instruction as well.
Yes.
Okay, but that can be an issue, right? So which return instruction to be executed first? Means, let us say that, okay, so this is return for the call y. Okay, then there is another return instruction that is for call x. So if it is, earlier it had to be executed like this, but now if this return is executed beforehand, then the intention of the call instruction changes, right?
But how we can do that? I mean, for example, if a function is jump function, in that I want to use a specific function. Let us say one function is executing multiple functions.
Okay.
Generally, we are doing this in a real case scenario.
Yeah. So it is like you are trying to implement an ALU, some sort of.
Yes.
Yeah, then the best practice what it will be is not to declare it in the same subroutine. You can do two separate subroutine, because you see that this is a problem.
Yes.
Okay, so that is why it is better to have two separate subroutines instead of having, okay, I understood that you wanted to have a superset and you want to pick a subset of the operations, not everything.
Yes.
But
yes,
this particular issue that having multiple return statements, it is going to like make the code unusable, like for the actual purpose why it was made. So it is not going to satisfy that, right? So to prevent such kind of situation, usually these kind of good practices are adopted, that you keep these things separate. You keep the subroutine separate.
But our code size is going to increase because of this, because we do have a separate subroutines.
Yes, true. But yeah, that is the trade-off we need to take care of, like correctness versus the efficient use of memory.
Yeah.
Okay, so let me recap what we covered today. Okay, so in today's session what we covered is, so the first question was related to stack pointer, and the stack pointer always points to the top of the stack. Okay, then the question was related to an instruction called CNC, and we had to figure out what does CNC do. So CC, CNC, so these are the instructions that is used for conditional call. Okay, so conditional call is if a particular condition is met, then you perform the call subroutine operation. Okay, and CC stands for call the subroutine if carry flag is set, and CNC stands for call the subroutine if carry flag is not set. So CNC means if carry flag is not set, you call this particular subroutine which is located at location 4000.h. Okay. The next question was, which of the following instructions control the interrupt enable flip-flop? Okay, so we have a flip-flop available in the 8085 microprocessor, and it can be the interrupt enable flip-flop is controlled using two instructions, that is EI or DI, enable interrupt and disable interrupt. Okay, so the next question was related to which of the following instruction is equivalent to call 0028h. So basically RST0 is actually call 0000H. Okay, so similarly if it is 0028, so 0028 is actually, this is in hexadecimal. Okay, so it will be 2 into 16 plus 8, that is 32 plus 8 is equal to 40. So each such instruction, RST1 is at an offset of 8. Okay, RST2 is again at an offset of 8, but it is in hexadecimal, so it will be 10, because 8 plus 8 should be 16, and in hexadecimal if this bit is set, it will mean 16. So similarly, if this value is 40, okay, so 40 means it will be at an offset of 40 by 8, that is 5, right? So it is basically RST5. Okay, so which of the following instruction is equivalent to call 0028H? That is RST5. Okay, so these things are already covered in the lecture slide, and so I'll suggest you to go through them. So
एक बार रिपीट कर देंगे सर?
जी जी. So the thing is, each RST instruction, okay, it is mapped to a call address starting from 000H. Okay, so RST00 refers to call 000H, and with each increment of 1, like RST1, so there has to be an increment of 8 in the address. Okay, similarly RST2 will have an increment of 8 from the previous address, so it should be 8 plus 8, that is 16 in binary, sorry, in decimal. So in hexadecimal it will be 10.
Okay, sir.
Okay, so similarly what we are given is call 0028H. Okay, and we need to figure out what is this thing equivalent to. So 0028H matlab it is 40, right? And 40 means because each address is at an offset of 8, so 40
in hexa, 40 in hexa.
No, this is 40 in decimal. So what I did is 0028H को मैंने convert कर दिया 40 decimal में.
ठीक है, ओके.
ओके, तो 14 डेसिमल का मतलब क्या है कि कितने ऑफसेट पे होगा वो. अगर मैं डिवाइड बाय 8 करूँगा मुझे पता चल जाएगा.
यस सर.
ओके, सो दैट इज व्हाट आई डिड, एंड सो as it is 5, so RST5 is the equivalent to call 0028H. Okay, I hope this is clear.
Yes sir.
Okay, so similarly the next question is related to number of T states that are required by the 8085 microprocessor to execute CNC instruction. Okay, so this is something you need to remember, that it needs 18 T states. Okay, and the next question is related to how long should INTR interrupt remain high to be sensed by 8085 microprocessor. So it is 17.5 states. The reason is it has to stay high for the instruction which is going to take the maximum amount of time, and the instruction that takes the maximum amount of time is 18. Okay, sorry. Yes. The next question is related to the next question is related to set interrupt mask instruction. So sim instruction is used for setting the interrupt masks, and what it does is whatever is the content of accumulator, okay, based on that it sets the mask. Okay, so in this case, so we have this register and whatever value is being moved to A. So what is being moved to A is 2A. So 2A means 0 0 1 0, and A is, can anyone tell me what is A?
Later.
Sorry?
1010.
Okay. So it is 1010. Okay, so 0 0 1 0 1 0 1 0. Okay, so this will mean that so you can observe, right? So M6.5, at the M6.5 location, that bit is 1. Okay, so it means RST 6.5 interrupt is going to be masked. Okay, so let me do one thing. Let me write down what it is. So SOD is actually serial data out. SOE is enable serial data. So if it is 0, then ignore bit 7. If it is 1, then send data, send bit 7, bit 7 to SOD. Okay, so this one is not used, so it doesn't matter whatever the value is. RST 7.5 means reset 7.5. MSC means mask set enable. So if it is 0, then ignore bits 0 to 2. If it is 1, means set the masks according to bits 0 to 2. Okay, then the remaining bits, if it is masked, then it will be equal to 1. If it is unmasked, then it will be equal to 0. Okay, so let us say what I do is I do EI MVI A comma 2 BH SIN. So can anyone tell me what is actually going to happen in this case? So we did for MVI A 2AH, right? So similarly, if it would have been 2BH, can anyone tell me?
Sir, we put 1 0 1. We put
1 0
1 1.
1 1. Okay, so 1 0 1 1 will mean
The last bit,
yeah, the last bit will be 1. M 6.5 will also be 1, and because this MSC bit is 1, so what will happen is M6 so RST 6.5 and RST 5.5, both of the interrupt will be masked. Okay, so similarly, if any configuration is given to you, you just need to look at the value that is being fed to the accumulator, and based on that you set the interrupt mask. Okay, or you perform whatever operation is needed. Okay, had it been something like this 0 0 1 1, okay, then remember that it is not going to set 7.5, but it is going to reset 7.5, like RST 7.5. Okay, So you need to be careful, but just remember the configuration, this entire thing that I wrote here, right? So just remember this, and based on that, whatever question arises, so you just look at the values that are present in the accumulator, okay, and then perform this.
The previous question में calculate T states सर कैसे calculate करते हैं, एक बार बता देते हैं. T states
नहीं, हमने एक्चुअली कैलकुलेट नहीं किया, तो ये कुछ चीज़ें हैं जो हमको मतलब याद रखना पड़ता है, ठीक है. तो लास्ट टाइम मैंने क्या किया था, कुछ कॉमनली यूज्ड इंस्ट्रक्शन का टी स्टेट्स बताया था, बट हाँ, मैं नेक्स्ट सेशन में एक चीज़ करने वाला हूँ कि फॉर ईच इंस्ट्रक्शन हाउ कैन वी एस्टिमेट द नंबर ऑफ टी स्टेट्स फॉर दैट पर्टिकुलर इंस्ट्रक्शन. So I'll try to come up with an answer for this question in the next session. So 21 तारीख को और एक सेशन मैं कंडक्ट करने वाला हूँ, so that will revise whatever we have studied so far. Okay. तो उसमें I'll try to answer this question कि मतलब for a given instruction how to figure out the number of T states. Otherwise the best thing is, so you have some commonly used instruction like move and move, add, and those things, right? So for them the T states are already mentioned in the lecture notes. Also I wrote it in the previous session, so you can refer to that. Okay, so that because वही सारे instructions ही ज़्यादातर use होते हैं and ज़्यादातर questions में वही आते हैं, ठीक है. तो आप एक बार देख सकते हैं उसे. Okay. The next question that we did is in question number 9, we were supposed to figure out, so which of the following is not a valid 8085 instruction. Okay, so the answer is, so push, pop, both the instructions are used on a register pair, right? And if you do pop C, then it doesn't make sense, because if you do pop B, then it will push the content of B and C. Sorry, it will pop the content of B and C. But for pop C it doesn't make sense because we need to mention a register pair, right? So pop C is not a valid instruction. Okay, then question 10 was related to whether something is edge, the instructions are edge triggered or the interrupts are edge triggered or level triggered. So this is also a factual question. It is mentioned in the lecture notes, you can go through them. But just remember which interrupt is edge triggered and which is level triggered, because this question is a bit commonly asked, so it will be better to remember them. And what does edge triggered mean? Edge triggered means that whenever a positive edge or a negative edge, okay, so edge means anything that is appearing at the point of transition. So when you are moving from 0 to 1, the point of transition is this particular thing, right? So that's a positive edge because you are moving into the positive direction. And this is called as a negative edge because you are actually decrementing the value of 1 to 0. That's a negative edge, right? So these are the edges, and if anything is sensitive to those edges, it is called as edge triggered. Okay, and it won't change its value until and unless another edge appears. But in case of a level triggered logic, okay, so let us say that if any system is edge triggered, okay, so let's say it is positive edge triggered, then what is going to happen is, okay, let me change the pulse width like this so it will be better. If a system is positive edge triggered, then it will become high during this time and it will stay high. Okay, it will stay high or it will hold its value until there is another change that appears at the next edge. Okay, let us say the function is if positive edge, then it should be equal to 1. If negative edge, then it should be equal to 0. So if that is the case, so during positive edge this will be 1 and negative edge it will be 0. okay, let us not bring negative edge. If positive edge is arrived once, then you stay high like this. Okay, so it means if positive edge is arrived here, so it will stay high till the next positive edge arrives. Okay, so the next positive edge can be any value, so it will change according to that. But let us say if something is sensitive to the levels, so it means that the moment it goes to 0, it stops being active. Okay, so that is what edge triggered and level triggered means. And there are a few instructions that are like both edge as well as level triggered. So RST 4.5 was one of them, and you need to remember these things. Okay, then the next question that we did was related to the flags. So what we needed to answer is which of the following instructions do not affect the flag. So data transfer operations like move instruction, they do not affect the flag. Okay, this was related to question 11. Similarly for question 13, okay, 12 is missed. Okay, question 13, we had to figure out which registers can be together used as an accumulator register. So AL and AH together can be used as an accumulator register. Then for the execution unit in 8086, so which of the following is performed? So it is the instruction execution that is performed by this instruction. So this is what we covered in today's session. And yeah, so for those who joined late, so I made an announcement in the beginning that next week 21st, what I will be doing is I will be going through all the lectures that we have, all the live sessions we have covered so far from week 1 till today. Okay, and I will be choosing all the important concepts that we covered from problem solving point of view. We won't be covering anything factual there. Okay, so from problem solving point of view, there's a good number of questions that we have solved so far. That is roughly 15 questions per session, so that translates to around 180 questions we have solved so far. So what I will suggest you to do is, so you try to go through whatever live recording lectures are available, and whatever annotated notes are shared, means whatever notes are shared for the live sessions that I have uploaded on the Google Drive, you can go through them. So anywhere you have a doubt, just keep it noted down. You can ask me during that session itself. Okay, and as your exam is on 28th, so that will be a good revision for you. So all the concepts, all the important concepts, all the important numericals, I'll pick them from whatever questions we have solved so far, and that will be discussed next.
all week के सब questions from
हाँ ऑल वीक के, मतलब week 1 से लेके week 12 तक.
okay.
ठीक है, सो आई विल ट्राई टू, मतलब जितने न्यूमेरिकल्स किए थे, सो देयर वोंट बी एनी फैक्चुअल क्वेश्चंस लाइक दिस. लाइक क्वेश्चन 14 इज अ मतलब फैक्ट बेस्ड ना, सो फैक्ट बेस्ड क्वेश्चन एनीवे यू हैव टू रिमेंबर, बट क्वेश्चंस विच नीड वर्किंग आउट, मतलब जैसे कि इसका 2 कॉम्प्लीमेंट क्या है एंड व्हाट इज 1's कॉम्प्लीमेंट ऑफ दिस, और समथिंग लाइक something related to finite state machine, the questions that we solved earlier.
So timing क्या आपकी?
So
Timing क्या रहेगी?
timing is 3 to 5 p.m. Saturday. So 21st 3 p.m. to 5 p.m.
21.
Sorry?
The 21st को ना सर?
जी 21st.
Okay.
ठीक है. So that is what we will do. So yeah. And before that, it will be good for you to give a brief look at the live session notes or the live session videos that we have covered. So that will be helpful. Okay. So yeah, that's all we had for today. Let's meet on 21st. Okay. And if you have any queries also, you can ask me on 21st itself. That will be helpful. Okay. Thank you everyone for joining. Okay, so I'll be around here. Just let me know if you have any query. Yeah, thanks Mukesh for joining. So if you have any question means related to any other week, so we can discuss it during the next session itself. So next session I'll be doing all the, like I'll be trying to cover almost all the problems that we have solved, means in terms of variety. When I say all, if anything is repeated, maybe I'll cover one of the repeated things, but yeah, so that will be helpful. And yeah, we will meet on 21st from 3 to 4. Hi Anuj. So do you want me to go through whatever questions we... Hello. Yeah. Hi everyone. So do you want me to go through the questions that we solved in today's sessions quickly? Hello. Okay, I'll give a quick run of this questions that we solved today. So Yeah, so the first question was related to stack pointer, and stack pointer always points to top of the stack. Okay. The next question was related to the operation that is performed by this instruction CNC 4001H. Okay. So CNC is a conditional call that is supported by the 8085 microprocessor. Okay. So other conditional calls, CC actually stands for you perform the call subroutine if the carry flag is set, and CNC stands for call subroutine if carry flag is not set. So CNC means carry flag. If carry flag is not set, then you execute the subroutine that is present at the location 4001. Okay. So the next question was related to the interrupt enable flip-flop, and what is being asked is which of the following instructions control the interrupt enable flip-flop. So enable interrupt and disable interrupt are the two instructions that are supported by 8085 for controlling the interrupt enable flip-flop. Okay. Then the next question was related to call 0028H. What is the equivalent of this instruction? So to figure out what is the equivalent, what we need to know is RST0 is called by call 000H. Okay, and every other call instruction to the RST registers, it is at an increment of 8. Okay, so similarly RST1 will be called by call 0008, RST2 will be called by call 0010H. Okay, so this is all in hexadecimal, right? So similarly, if we are given call 0028H, so what I did is I will translate this 0028H into decimal. So that is actually 40. Okay, so if it is 40, then if each instruction is at an offset of 8, so what I will do is I'll do 40 by 8 and I'll get 5. That points to RST5. Okay. The next question was how many T states are required by 8085 microprocessor to execute CNC instruction. So the answer is 18. Okay. Similarly, how long must INTR interrupt remain high to be sensed by 8085 microprocessor? So it should be high for the instruction which is going to take the maximum amount of time period, that is CNC. It takes 18 T states. So INTR should be high at least till that period, so 17.5 T states. Okay. The next question was related to the set interrupt mask option. Okay. So set interrupt mask, what it does is whatever is present in the accumulator, based on those values, it sets the interrupt mask. Okay. So the first thing we do is we see what is the value that is present at the accumulator. MVI instructions move 2A into the accumulator, and 2A means 00101010. So this is the entire register that is used for setting the interrupts. Okay. What we do is we map those values to these corresponding locations. Okay. Then based on the characteristic of each of this location, okay, I figure out what it is going to do. So I see that 1 is set here just above MSE. So MSE is mask set enable. Okay. If it is 0, then I need to ignore those bits, but it is set as 1. So I need to set the mask bits according to bit 0 to 2. And what I observe is this bit is also set. If that bit is set, it means I need to mask that particular RST. Okay. So RST 6.5 interrupt is masked. The next question that we did is related to validity of instruction POP. So POP instruction, it actually takes a register pair, but POP C can't take a register pair. It should be POP B. Okay, so POP B will take care of both B and C register. POP C is not a valid instruction in 8085. The next question was related to the sensitivity of the RSTs. So you need to remember this. Okay, so it is available in the lecture slides as well. You can go through them. Next question: which of the instructions do not affect the flags? Any kind of data transfer operation does not affect the flags. For example, move instruction. Okay. Next question was related to 8085 microprocessor, and the question was which of the following registers can be combined together to be used as an accumulator register. So AL and AH can be used. Then which of the following is performed by execution unit in 8086, that is instruction execution. Okay, so these were the questions that we covered today, and then in next week also we are going to have an additional session in which whatever important concepts we have solved from week 1 till today. So I will be covering all the important questions in the next week from 3 p.m. to 5 p.m. So 21st, that is Saturday, from 3 p.m. to 5 p.m. I'm going to cover that. So what I'll suggest is you can go through the lectures, you can go through the live sessions, the previous live sessions. It is available on my YouTube channel, and if you find any doubt, if you have a doubt, if you find any difficulty in understanding any particular question, you can let me know then and there. Okay, anyways, I'm going to cover those important problems. I'll try to cover almost every important problem, every variety of important problem that we solved so far. So roughly per day, per session, we have solved 15 problems. Total 12 weeks are over. So 180 problems I have solved so far. And from there, I'll cherry pick the important questions, problem solvings that we need to do. Okay. So yeah, that's all. If you have a question, let me know. Okay. Yeah. No issues, Anuj. Yeah, have a good day.